We're very fortunate today to have Andrew Bowerbank as our keynote speaker. Andrew is the Executive Director of the World Green Building Council.
And I love the fact that in the news, they talk about NASA sending some of the best technology that we're able to come up with. These rovers that fly to Mars. And they land on the planet, and they open up photovoltaic panels, and it drives out onto the landscape, and this little scoop comes out front, digging for all it's worth in the ground to try and find any other microbial example of life in the universe, and we're teaming with it here on the planet. Great, beautiful planet, right? But we take a look at the fact that the human population, according to the UN, is going to grow from 6.5 billion to 9 billion people by 2050. Okay? There are countries out there right now that are completely saturated with light pollution. I can't imagine not being able to drive an hour and a half north of Toronto and sit out under the stars in the summertime. There are countries that populations that can't do that, and I just can't fathom that sometimes. You look at the fact that the United Nations say that 50% of us right now live in urban centers. By 2050, 70% of us will be living in urban centers. Right now, there are 18 megacities on the planet, over 10 million in each city. That's going to grow to 27 megacities by 2050. There are only 3 other species on this planet that have been able to globalize the way we have: ants, termites, and bees. Bees are a restorative species, aren't they? And look at us. What does it take? What's our footprint to actually do what we do on this planet? David Suzuki said that the planet and the atmosphere is like skin on an onion. The atmosphere is that paper thin around the planet. So the first layer, the outermost layer, is called the thermosphere, about 60 kilometers above the planet. Next one is called the mesosphere, 35 kilometers thick. It's the coldest layer at minus 90 degrees. We then have the stratosphere, 40 kilometers thick, very rich in ozone. And finally, the troposphere, where we live. Only extends 12 kilometers above the planet, but contains 80% of the atmospheric gases. Let's put that in a bit of context. This is a picture of Mount Everest. Okay? About 9 kilometers tall, high. The troposphere extends 12 kilometers, but only half of the troposphere is actual breathable air. So when you have guys climbing up Mount Everest with oxygen masks on near the top, it's not because the air is getting thin. There is no air up there. And what do? We burn, we drill, we scrape, and we pump it all within that 6-kilometer area. Things are getting pretty tight, right? Only 18% of our energy right now comes from renewable sources. What we need to do is figure out a way to reverse that. We need to figure out a way to let renewables take a lot of the brunt of the work and allow fossil fuels to be used for essential services. But we can aspire. We can make a difference. And how do we do that? And part of my concern is a gentleman by the name of Ira Magaziner, who is one of the directors of the Clinton Climate Initiative, made a statement about 4 years ago in Denver, Colorado, at the Greenbuild conference there. 30,000 people a year go to this conference. So there are about 10,000 people in the plenary at the time, and listening to him say we had about 10 years to make a difference in climate change, or we're living with the consequences. Now here's the thing for me. When you look at what it takes to build a commercial building, whatever scale, and you go from design and drawings to permit approvals to building and construction to occupancy, what approximate time frame would you look at for something like that? And we have 10 years to make a difference in climate change? Mathematics isn't quite working for me yet. So we have to understand something, though. It's not about stopping climate change at this point. All right, people? It's about adaptation. It's adaptation to climate change. It's going to happen. The United Nations, through the Fourth Assessment Report put out in 2007, said a few controversial things. First of all, they felt that a 2-degree temperature increase in our planet is almost unavoidable. And we have to understand this is probably the greatest concentration of scientists around the world coming up with these numbers. A 3-degree temperature increase is most likely. The part that makes me nervous is they say it is unlikely as a species we are going to be able to survive anything above a 3-degree temperature increase. It doesn't mean us personally. It means the resources that we need to survive, knowing that our populations could be growing to 9 billion people, just aren't going to be there for us. The planet's going to shift dramatically. In order to stabilize temperatures at 2 to 3 degrees, emissions must remain under 450 parts per million. We're sitting at 430 parts per million right now. Very close. To achieve reductions that will work, we need to look at achieving 50 to 85% emission reductions, okay, by 2030. That would put us around 2 to 2.4 degree increase in the temperature increase, okay? Option 2 is take a bit more time and achieve a 30 to 60% emission reduction, but the problem is that puts us really close to that 3 degree tipping point, and I'm not sure if I like the idea of my families growing up living on this concern of this tipping point of climate disaster. The planet's going to be here for how much longer, spinning away, okay? And we have to realize that we're not trying to save the planet right now. It's going to keep spinning. We're trying to ensure our survival on it. I watched a TV show a few months back, I think it was on Discovery Channel, and sort of just talking about what would it be like if we were to disappear off this planet right now. Everybody just disappeared. And they said basically the Earth could rebalance itself in about 150 years in the atmosphere with CO2 emissions. 150 years, that's quick. And the planet could probably swallow up any evidence that we were even here in about 800 years, except for things that are made out of stainless steel. So all of a sudden you've got kitchen knives and kitchen sinks everywhere, and, you know, and that's it. So I mean, you have to think about these kind of numbers. So let's get off the Al Gore conversation and let's look at how.